Welcome back. Now we are in Module 6, Lesson 6, which is the last lesson of this module. So we are looking at describe and sketch nonlinear functions, the I can statement. I can convert between a verbal description of a function and its graph, and between a graph and its verbal description of a function. So remember, this time they're really talking mostly about nonlinear functions. So let's look at number 1 of the step it out. And this is like the last lesson. There's no spark your learning or build understanding. It goes right to the step it out. So number 1, Emmanuel walks the North Trail at his local park. The graph shows his distance from the fountain at the center of the park as he walks along the trail. Use the graph to answer the questions. So again, always pay attention to what are they describing on the x-axis and what is happening with the y-axis. So the x-axis here is the distance on the trail itself. This is telling his distance away from the fountain that's at the center of the park. So let's keep those things in mind as we look at the questions. So each section of the graph is linear or nonlinear. So you can see there are 3 different sections of the graph. So they're asking, is each section linear or nonlinear? B, the slope for the first part of his walk, and they're asking, is it positive or negative? Which means his distance from the fountain is either increasing or decreasing. So again, look at, this is the distance on the trail, this is the distance from the fountain. So think about whether this first part is positive or negative, the slope, and whether that his distance from the fountain is increasing or decreasing at a constant rate. C, the slope for the second part of his walk right here is what? And then what does this mean about his distance from the fountain? Again, here's his distance from the fountain. Is that increasing, decreasing? What's happening there? And then D, the slope for the third part of his walk, they want to know again, is that positive or negative? And then whichever that is, that would mean his distance from the fountain is either increasing or decreasing at a constant rate. E, Emmanuel returns to the park the next day and walks the South Trail. So here they're looking at this graph. The South Trail graph, is that linear or nonlinear? And remember, linear is in a straight line. Nonlinear would not be in a straight line. F, early on, does his distance from the fountain decrease at a constant rate? So remember again, what does it mean when it's a linear graph versus a nonlinear graph? And you can go back and look at previous lessons if you need to have some help remembering that. Near the end, does his distance, so this first one early on, they're talking about this portion, and then they're saying near the end, does this distance from the fountain increase at a constant rate? Yes or no? And how do you know? So work on those, pause the video, work on those questions. You can also do this turn and talk. Describe potential scenarios for each path in relation to the fountain location. So think about, you could even draw a picture maybe of what the park might look like with a fountain at the center and the different trails. So you could work on that as well. So pause the video, work on number 1, and then we'll go on to number 2. So now let's look at number 2. When a state fair opened, the number of people attending the fair gradually increased at a constant rate. Remember that. In the morning, then the number of people remained constant through the afternoon. Then in the evening, the attendance gradually decreased at a constant rate until near the end of the night, when the number of people decreased swiftly at a constant rate as they all left. So A, where should the graph of the situation begin and why? Is it going to start at 0? Is it going to start somewhere above 0? Because were there any people there when the fair opened other than the workers? They're talking about attendees. B, describe what happens to the graph as the number of people gradually increased at a constant rate in the morning. Will the slope of this part of the graph be positive or negative? Will it be steep or gradual? And so here's where you'll choose the answer for those. C, describe what the graph looks like as the number of people remained constant throughout the afternoon. this part of the graph will be what? D, describe what happens as to the graph as the number of people gradually decreased at a constant rate. Will the slope of this part of the graph be positive or negative? Will it be steep or gradual? So you'll answer those questions here. E, describe what happens to the graph near the end of the night when the number of people decreased swiftly as they all left. Will the slope of this part of the graph be positive or negative? Will it be steep or gradual? And so you'll answer those two questions there. And then F, use what you described to sketch the situation. So you're going to kind of create a graph to describe what's happening. G, suppose the number of people attending the fair continued to gradually increase at the same constant rate throughout the afternoon instead of remaining constant. Sketch a graph that represents this situation. So pause here, work on that, and then we can go to the next section. So on number 3, Kevin says this graph describes an airplane that takes off, climbs to a cruising altitude, stays at the cruising altitude for the flight, then descends for the landing. Kate says that the graph better describes a model rocket that launches, rises to a maximum altitude, and then falls faster and faster until it reaches the ground. So then they ask you some questions. Is the graph linear, nonlinear, or a combination? B, is the graph increasing at a constant rate? So is this a constant rate of increase? Is the graph decreasing at a constant rate? Is this constant? And remember, a linear graph is something that increases or decreases at a constant rate. C, is there a portion of the graph where the altitude is constant? So this is the top altitude. Is there a place where that remains constant for an extended period of time? D, whose description does the graph better represent, Kevin's or Kate's, and why? So work on that one. So pause here, work on that. When you feel good about your work, you can go to the check understanding. Once you finish the check understanding and you feel okay and you feel like you've got this information down, you can go on to the on your own. These next 2 pages are a continuation of the on your own. So there are 16 problems in all for the on your own. This page here is the more practice homework. If you feel like the on your own wasn't quite enough, you can do some or all of those problems. Then you can go on and do the test prep and the spiral review. And then again, because this is the last lesson in the module, this is the end of module 6, this is a good idea to do this review. You don't have to do it right the same day, but it's always a good idea before you go on to the next module to do this review, just to review vocabulary, concepts, skills, things that you've learned in this module. So work on this whenever you can, and then we'll go to module 7.